Hello, welcome to our video about solving three variable systems by hand. When solving a three variable system, you have a lot of options. If you are not permitted the use of a graphing utility, then your options are to use substitution, or elimination. I'm personally a fan of elimination. I think it's a little bit more efficient and you're less likely to do errors. You can always substitute. In this video, I'll give you an example of how to substitute, but I think elimination is usually the way to go. So basically, to solve a three variable system, you have to try to make it a two variable system. And then you can find your independent variables and work your way back up. So first, look at your equations, and you want to pick one variable to try to eliminate from all three, which can be a bit of a challenge. But you want to look at the easiest way to do it, in my personal opinion. And I see right away, if I look at the bottom two, I have a negative 3x and a positive 3x, which means if I add these two equations together right now, in fact, I'll write that over here just so we have it as a reference, negative 3x minus 2x, or 2y, plus 7z, and then I have 3x plus 3y minus 4z equals 7. If I take those two and I add them together right away, the x's will cancel out, and then I will be left with negative 2y plus 3y, which is just y. Then I have 7z minus 4z, which makes 3z. And then 5 plus 7, which is 12. So that was pretty simple. I didn't have to do much thinking. So then I have to use this equation, the equation I didn't use before, and I have to get rid of x. So I can combine it with either the second equation or the third equation, doesn't really matter. Whichever one is easiest. And in this case, I don't know if one is necessarily easier than the other, but I will look at these two and try to eliminate a variable. So I will write them down here, just so we have it as a reference. And then I have negative 3x minus 2y plus 7z. Again, when we're doing this, you want to go back to the original equation. You don't want to try to manipulate this equation over here that I have in purple just yet. Okay, so again, right now, since I chose to eliminate variable x over here, I have to eliminate x here. Even though the y might be easier to get rid of, that doesn't actually help me if I try to get rid of the y right now. So, which means I have to multiply both equations by something, because they don't really have anything in common. So I would multiply this top one by a 3 and the bottom one by a 2. They already have opposite signs, so that makes life a little bit easier on me. So this makes 6x plus 2y plus 9z equals 30. Again, common mistake is that people don't multiply to the final number there. So just make sure you watch yourself. And then negative 6x, negative 2y, time out. This should be a 3y. Sorry. And this should be a negative 4. See, this is why you want to make sure you're taking your time. And then we have positive 14z, and then 10. We're going to add those. Those cancel, which is what we designed it to do. And then I have y. 9z plus 14z would be 23z, which seems a little odd, but just roll with it. I think we're doing okay so far. So now we can either do substitution or eliminating with these two. Again, now we're trying to figure out one variable. It's pretty simple to me right now, or at least it feels like it is, to, this should be a negative. Just add the two together right now. So negative y plus 23z equals 40. And then I have y plus 3z equals 12. I can add them up right now and they'll cancel. So this is 26z equals 52, which means that z equals 2. And now I just have to work my way back up. So if I know z equals 2, let's grab this equation down here and we'll plug in z. So y plus 3 times 2 equals 12. 3 times 2 is 6, so that means that y has to equal 12 minus 6, which is 6. So I got z, I got y. Go ahead when you're doing this and take your time. Take your time and make sure that you're doing it right as you go. Because if you go all the way back up to the top and you mess up, it's going to be very heartbreaking to have to go back. So you can even go over here and check and just pop in negative 6 right here and 2 for z and make sure that you get 40. So this is 23 times 2, which is 46. Negative 6 plus 46 is 40. Cool. So we're good. So we know that one's good and that one's good based on what we have. Okay, so now we got to work our way all the way back to the beginning. We know that z is 2 and y is 6. You can pick any one of your original equations. Again, I always go back to the originals. If I've manipulated equations a whole lot, I always like to go back to the beginning. Let's just plug it into the top one. So I've got 2x, which is what I'm trying to find. I'm trying to find x. And then I have plus y, which is 6. And then I have 3z. Z is 2, which equals 10. This is 2x plus 12 equals 10. So 2x equals negative 2, so x equals negative 1. So your point in your three-dimensional system would be the point negative 1, 6, 2. Again, you can do substitution. Like if you isolated y, you could then plug in that equation in for that and then for this, but you're going to end up having to do a lot of distributing. It's distributing in negative as well. I would avoid doing substitution unless it's a very easy, obvious substitution. All right, go ahead and try some on your own, and as always, make good choices.